So let's begin our discussion with logs and exponential. This is one of the simplest topic in math. I believe you will be able to know it by the end of this week, and you'll be able to solve almost any type of question under log. So we start. Initially, when we're talking about log and exponential, these things is like they are cousins. Okay? So if you have got an exponential, if you take the inverse, then that is going to be a log. If you have got a log, you take the inverse, that is going to be exponential. So that's why I'm saying it's like these two guys, they are cousins. So if you take the inverse of log, you are going to have exponential. You take the inverse of exponential, you are going to have a log. Okay? Now, one thing we need to know, guys, under log, we need first to talk about the basics of log. So let's start with our log before we go to exponential. So logarithm, from the word itself, they are going to use L. This is log. When you see someone writing log or natural n or ln, this is what we call logarithm. Anything to the power x or e to the power x, this is what we call exponential. So this is logarithm. Logarithm. Then this is exponential. Understanding this is very important for you to also understand calculus when it comes for the differentiation of log and exponential. It's going to be easy. Okay? Now, the basics of logarithm, which you have to understand today, is this. If I happen to have log base a of b to be equal to x, okay, this is the same as I can, the property of log allows me to shift the base. Sorry, not the base. This, if I've got a power, or let me start from here, I can confuse you. If I've got log base a of b to be equal to c, this is what we call log. But we are saying that these are cousins, so they can be together, they can be staying together. So I can change this log into exponential. When we're talking about exponential, it's supposed to be a number to the power something. So I can convert this to be what? Exponential. So converting this into exponential, what you have to do is you get the power raised to the power what is it outside is equal to what is outside. What do I mean? A raised to the power c is equal to b. It is exactly as log base a, b is equal to c. Have you seen what I've done? So if I've got log base 2 of 3 is equal to x, changing this into exponential is going to be 2, the base raised to the power of what is outside is equal to what is inside. So the base raised to the power x is equal to 3. I've changed now from log into exponential. Question 5 is telling us to say rewrite each of the following expression in exponential form. The first question is log base 1 over 6, 36 is equal to negative 2. So the only thing here is just get the base 1 over 6. This has to be raised to the power what is outside is equal to what is inside. As simple as that. You can solve the rest. Who can tell me part B? What B is going to be from what I've given you here?
Sorry, can you repeat? I didn't get you clear.
I'm going to use B as an example. So if we have got log base 12 of 20,736 to be equal to 4, we are trying to convert this from log into exponential. So putting this into exponential, you get the base raised to the power what is outside should be equal to what is inside. So 12 raised to the power 4 is equal to 20,736, meaning I've converted now from log into exponential. Esther, you okay there?
Yes, sir.
Okay, so tell me what C is going to be if you're okay. Mm-hmm.
Uh, C is going to be 9
Mm-hmm.
to the power 5 over 2
Mm-hmm.
equals 242.
Perfect. So we have converted this in from log into exponential. Anyone who can tell me part D? Let's do first. Anyone who can tell me part D? David. Matthews. Yes. Tell us part D. Part D, yes. Okay, who can tell us part D?
So I can write try.
Yes.
4
Mm-hmm.
to the power negative 7 over 2
Mm-hmm.
equals 1 over 4.
Okay.
No, sorry, equals 1 over 2, 128.
128. Okay. Now, this is exactly as the same as if we go to question 6. That is exponential now. How do you come from exponential now? I've given you an example to say if I've got log base 2 of 3 is equal to x. Then converting this from exponential, from log to exponential, it is 2 raised to the power x is equal to 3. Now, what if we have got this, we want to take it back to log? That is what we have on 6. You have seen, right? Rewrite each of the following expression in logarithmic form. So now, rewriting this into exponential, if I have got 2 to the power x is equal to 3. Rewriting this into exponential or into log, I know that I need just to write log. What you have here, the one which is having the power, is the base. The one which is outside is the one which is going to be here. The power is the one which is going to be outside. You get me, right? Now, let me give you a very simple example, which is B. 4 raised to the power 7 is equal to 16,384. Rewriting this into log, I need just to write log. This 4 is going to be the base because it's the one which is containing the power. So it's going to be the base. The power is going to be what is going to be outside. Okay, but before I write that, what is outside here is going to be inside. 16,384 should be equal to 7. These are basics, not so? Who is behind there? Mm-hmm. Estere.
Just explain. explain one last time.
So we are saying we have started from here. We have started from here, Esther. We said if we have log base 2 of x, okay, base 2 of 3, or let's say base 2 of 4 is equal to x. Not so. So converting this from log into exponential, we said is going to be what, Esther? Converting this into exponential.
The 2 to the power x is equals to 3 to 4, I mean.
It is equal to 4. But what if we the we are trying to hide this and then we tell you to say take it back to log? You get my point, right? 2 to the power x is equal to 4. Take it back to log. So we want exact as log 2 of 4 is equal to x. So you say you first write log, then what the anything which has got power is going to be the base. So it's going to be log base 2. What is outside is the one which is going to be here, is equal to the power. The power is going to be outside. We have taken it back to that. Does that make sense?
Yes, sir.
Now, I've used this example now, Esther. I've used question B, which is 4 raised to the power 7 to be equal to 16,384. Let's take it back to log. So we know that we need first to write log. What will be the base, Esther? What will be the base?
The base will be 4.
Will be 4. Then what is outside here is going to be inside here. 16,384 should be equal to the power. We have taken it back to log from exponential. I can again take it back to exponential to say 4 raised to the power 7 is equal to 16,384, meaning it's back to exponential. Is that hard?
No, sir. Thank you very much.
Okay, so now anyone who can tell me part A, what would be the answer for part A? I want a guy. Matthews.
Yes, sir. Part A to B.
Mm-hmm,
Log
mm-hmm,
11
mm-hmm.
power 1 over 1331.
So I put here 1 over.
Yes, 1
Mm-hmm,
3 3 1.
mm-hmm.
Then equals to negative 3.
Perfect. Who can tell me part D? Who can tell me part D?
So part D, that will be log 25.
Okay, just a minute.
Then you raise it to
Log 25. Mm-hmm,
yeah. So you raise it to 125.
mm-hmm.
Then is equal to 3 over 2.
Okay, perfect. So I believe you can do C and E, not so? Hmm?
Yes.
Okay. So now these are basics. So we are building up. Let's go to the next step. So without using a calculator, let's try to find the values of this log. Okay? Let me give the basic rules of log. Now, if I have got log base 2 of 2 to the power 3, okay? Or let me do this. Log base A of b to the power c. Have you seen what it is? Base A b to the power c. This is the same as the property of log allows you to shift the power to be in front. So this is the same as c log base A of b. Have you seen what I've done? Have you seen what I've done? If you come across any question on log, they give you log base, they don't indicate any base, just know that it's in base 10. They have not given you, you have just been given a log with something, let's say log of 2, meaning it's in base what? Hmm?
of 10.
Of 10. So if they have not indicated any base, just know that it's in base 10. Now there are two things which you need to be familiar with. I mentioned of when we're talking about log, we are talking about this log which is log and ln which is natural log. Okay, so natural log is always in base what e, but they are not going to indicate it that is in base e. But you should know from today that natural log is always in base e. Is that okay? Then there are some things which you need to know, which are log, regardless of any base, log 1 and log 0. I've mentioned it. Regardless of any base, it can be in any base. As long as you see log 0, but most is going to be log 1, not log 0. So we just focus on log 1. Okay. Regardless of any base, as long as you come across log 1, that's 0. I want you to know this. It can be in any base. As long as there is 1 inside here, then it is 0. The answer is 0. Esther, tell me the answer of this. What is log base 2 of 1?
It's 0.
It's 0. Any base, regardless of any base, as long as inside here there is 1, it's 0. Get me right there. Another issue, guys, is regardless of any base, as long as you have got log 0 inside here, it is undefined. It doesn't exist. So what is log 3 of 0? Hmm?
It's undefined.
It's undefined. It doesn't exist. These are the things I want you to know, because you come across these. You come across these. You are still there, right? You are getting me?
This is
Okay. Now let's do natural log. So if I've got ln 1, ln you always have, there's nothing like regardless of the base. The base is always e, but they're not going to show you. So ln is always in base e. So ln 1 is the same as log 1. So what is the answer? 0. Okay? Then what of ln 0? Since I've told you that this is the same as log, what is ln 0?
still remains undefined.
Still remains undefined. So this is going to be undefined as well. Okay? Now, Let's try to find how do we tend to find the exact value of a log. For example, if I've got log base 2 of 2 to the power 3, I have told you guys to say the property of log allows us to shift the power to be in front. So this is going to be 3 log 2 of 2. So log of base itself is equal to 1. So for example here log base 2 of 2 is going to be equal to 1. So as long as you have got log base of itself, then the answer is 1. So this part here is giving me 1. Therefore it's going to be 3 times 1, which is 3. Have I made myself clear?
No, sir.
What's the problem, Esther?
So I received the phone call. So the network was Shan. That's Shan. Yeah, Shan. Yes, sir.
Yashirashita shani, Esther. Ah, I don't understand, Bemba. Yashirashita shani.
Yeah, I was catching the call because once I log out, I won't enter again. Please explain some how you found it. Like
So we are saying log, we are saying log base of itself. What I mean base of itself is if you tend to have log base 3 of 3. You get my point, eh? Base 3 of 3. That's why I'm saying the log of base itself. So it's log 3 base 3. So it's the log base of itself. So itself, I'm talking about this guy here. So it's always 1. Okay? You get my point, right? So now I gave you an example of saying, what if we have log base 2 of 2 to the power 3? Now we are trying to find the exact value of log base 2 of 2 to the power 3. So the property of log allows us to shift the power to be in front. So this is going to be 3 log 2 of 2. So you clearly know the answer for this guy. What's the answer, Esther? Log base 2 of 2. Hmm? Esther. So what's the answer for log base 2 of 2?
1.
1. So that's why we say this 3 times 1, which is 3. You have seen, ka?
Yes, sir.
Okay.
So if the two are the same, it's just 1 then.
Yes, yes. If the two are the same, it's just 1. Now, when you come across any question which they're asking you to find the exact value, the only possible way, because you're not using a calculator. For example, let me give you this. Log of 2, 8. Find the exact value of log base 2 of 8. You get my point, right? You need to make this 8, you need to make this guy inside here to be exact as, you need to make it as exact as the base, and then you raise it to the power. You know what I mean, right? Because 8 is the same as what? 2 to the power 3. So 2 and 2 can give me 1. Then I can drop 3. The best example which I can give you now, right now, is which one? Okay. Log base 3 of 9. What would be the answer here? This is the same as what? I can write this as what? Come on, guys. I can write this as what? I want to make it as the same as, I want to make it to have 3 has to exist there.
There it will be. There it will be. To be log 3
Mm-hmm.
3 then power 3,
Okay.
3 of 3 again.
Then on top I should put 3.
Yes.
So if you say 3 to the power 3, what is 3 to the power 3, sir?
Oh, no, no, sir, it's 2, 2, power 2, sorry, 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 power 2.
Power 2. Because 3 to the power 2 is 9. So it's the same as 9. Then now I can shift 2 to be in front. So it will be 2 log 3 of 3. And I know that this is 1. So it's going to be 2 times 1, which is 2. You have seen, ka? That's what's happening there. Now let's go back to our question. So the question is determine the exact value of each of the following without using a calculator. So the first which we have is log base 7 of 343. We need to find a number which we raise to 7, which is going to give me 343. What number is that? Hmm? Because 7 to the power 2 is 49. What of 7 to the power 3? Guys, these are things. 7 to the power 2 is 49. So you say 49 times 3 or times 7 again. Any number to the power times 9, we just do this 64. Is this correct? 1, 2, 3, 4, 5, 6, 7. 63, right?
It will give us 343.
343. So this is the same as log base 7 of 7 to the power 3. We know that the property of log allows us to shift the power to be in front. 3 log 7 of 7. So this is going to give me 1. Therefore, the final answer will be 3. That's the exact value without using a calculator.
What if you use a calculator, sir? What if you use a calculator?
They can't give you that question if you're using a calculator.
Okay, 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 sir.
It's not,
I get it now.
yes, it's not possible. Because they know that, meaning that then they are just wasting their time. Because it's the same as 2 times 2 without using a calculator. Then they bring it when you have got a calculator. So they can't bring it. Another thing is I'll jump to, okay, let's deal with B. B is log base 4 of 1024. Mm-hmm. Find a number which can be raised to 4 should give us 1024. What number can be that? Now you know that 4 to the power 4 is what? 4 to the power 4 is 256. Then you should try now maybe 16. We don't know. 4 raised to the power 16. That's going to be a very big number. Yes, Matthews.
Yes, sir. There it will be 4 to the power 5.
4 to the power 5,
Yes.
1024, right?
Yes.
So it's going to be log 4 to the power 5. Shift 5 to be in front. 5 log 4 of 4. So the answer is 5. Should I show you another way on how to find the exact value?
Yes.
This is
Yes.
this is
Sure.
this is a bit complicated for you, I know, right? But it's the same. You can do this. You can say log base 7 of 343 equate it equal to anything, equate it equal to x. So you are solving for x, right? You have seen what I've done, right?
Yes.
So you have now, you convert this into exponential. You know I've already taught you how to convert into exponential. So it will be 7 raised to the power x is equal to 343. Although it's the same thing. When you have got something like this, what do? You still do the same. So it's going to be 7 raised to the power x is equal to, you find a number which can be raised so that the base should cancel out. So it will be 7 raised to the power 3. Then 7 and 7 will cancel. It's the same thing. X will be equal to 3. So the exact value is 3. This method which I'm teaching you, it can help you to solve a special question, the last question, which is log base 16 of 4, you equate x. So it's going to be log to the 16 to the power x is equal to 4. You see what I've done? So what are you going to do to make the base to be the same? This is the same as to the power 1. You can say 4 raised to the power what? 4 raised to the power 2. Then I've got x now is equal to 4 to the power 1. 4 and 4 can cancel the base. So you equate the powers. 2x will be equal to 1. Divide both sides by 2. 2x will be equal to half. So the exact value of log base 16 of 4 is half. Still brown. Still brownie.
But can you try to do the poem that was the function?
Yes, we are doing it. So we do C. So C is log base 3 of 2, or 3 base 8. Then that is 27 or 5, like that. 27 on top, divided by 5, 12. The best thing here is I can just tell you to say equate equal to x. So it's going to be 3 over 8 raised to the power what? Raised to the power x is equal to 27 over 5, 12. You have seen what I've done, right? What do we do next
Yes, sir.
to make things simple and straightforward? The next thing what I'm going to do here is um, do you understand the fact that if I do you guys know that 1 divided by 2 is the same as 2 to the power negative 1? You don't know.
Yes, yes, yes.
You know that, right?
Yes, we know that.
To make things simple, I'm going to say if I have 3 raised to the power 8 is the same as 8 to the power negative 3. Isn't it the same?
It is, sir.
If you're behind, please let me know. What we are trying to do here is this. If you have got 2 raised to the power 3, if you have got your calculator right now, if you punch 2 divided by 3, you discover that it's 0.66666. Then 0.66, if you don't believe that this is the same as 3 to the power negative 2, you can do 3 raised to the power negative 2. What are you getting? I'm getting a different one. I don't know if it's just my calculator. But do you guys know that if I've got x, let me do this. Okay, do you understand but you're okay with this one, right? When I say 1 divided by 2, it's the same as 2 to the power negative 1. So now, if I have 27 there, then I also have 512 down there. Do you know that I can still make the base to be the same? What I mean, guys, is this. 27, I want to make 27 to be the same as 3. But it can be raised to the power what? That's the question. So I'm going to have 3 divided by 8 raised to the power x is equal to this 27 is the same as 3 to the power 3. Then 512 is the same as what? I want to make it, because down here I've got 8. I want the base to cancel out. So 8 raised to the power what number can it be? 512. Try 8 squared is 64. Then 8 to the power 3. What of 8 to the power 3?
8 to the power 3 gives us 512.
512. So you say 8 to the power 3. What does it tells you? Since on top here I've got 3, down here I've got 3, then I can write this as 3 over 8 to the power x to be equal to 3 over 8 to the power 3, because it's the same thing. Then the base can go. You equate the power. X will be equal to 3. That's the simplest way, I think. You have seen what I've done. Have you seen what I've done? Or you are still confused? Which other one do you want us to do? Let's try G. G is log. There is no base. I told you guys, if there is no base, what is the base?
10.
10. So the best way, just equate x. So it's the same as what? Let's convert this from log into exponential. It's going to be what? It's going to be what? Hmm? The base, guys. We have the base already here. You know the base. I told you to say if they have not given you the base, you know the base. So the base is 10. So it is 10 raised to the power x is equal to 10,000. Let's make 10,000 to have base 10. So it's 10 raised to the power x is equal to 10 to the power what? 10 to the power, if we do 10 to the power 3 is what? Ten to the power 2 is 100. 100 times 10.
So it's going to be 10 to the power 4.
10 to the power 4. Because 100 times 10 is 1000. 1000 times 10 is 10,000. So 10 and 10 will go. Therefore, x is equal to 4. Let's try this, which is log base 0.1 of 0.0001. Just equate equal to x. Let's see. Let's solve for, we solve for what? For x. So it's going to be 0.1 to the power x is equal to 0.0001. How do we solve this? Don't you think that if we do, this is 1, 2, 3, I think it should be 3. If I do 0.1 to the power 3, it should be 0.0001. I don't know, but we can try. We try to do some math. So if we do 0.1 times 0.1, it's going to give me, okay, when you are multiplying these, it's the same as you can ignore the what? You can ignore the, you just say 0, 1 times 0, 1. So it's going to be 1 times 1 is 1, 1 times 0 is 0. So here 0, 0. So the final will be 1, 0, 0. So you count how many decimal places do we have? 1, 2. So we start from where? Where do we start from? I forgot 10. We start from here, 1, 2. So it's going to be here. So it's 0.01. And then this 0.0, so it's 0.001 times again 0.1. Definitely we're going to get 0.0. So it has to be to the power 4, I think. So we have 1, we have 0, 0. Then here we have also 0. Oh, we have 0, 0. This time that is 0. This time that is 0. What are we doing? Let me redo it from here. We are saying we have got 0.01. So again times 3. But it should be times 4. It should be to the power 4 also. Because if I add another 0, let's just do, laziness will not take us anywhere. So times 0, 0, 1. So this time that is 1, that will be 0, that will be 0. This time this is 0, 0, 0. So we end up having 1, 0, 0, 0. So we have now 1, 2, 3. So we have 0.001. So we are still remaining with 1. That's why I said it should be to the power 4. Have you seen? Have you seen? You're already behind, I think.
Yes.
Yes, sir.
Yes, sir.
So it will be 0.1 to the power 4. So x will be equal to 4. But the one who was making this tutorial sheet, I don't know what they were thinking. Why the answers are just 4? 4, 4. Which other one do you want us to solve? We have never solved for ln. Yeah? Let's go for ln. What? Natural log. Which is the natural log of the root of e raised to the power. Here there is 1 over 5. What does it mean when you say 1 over 5 there? Oh, it's like we have this, sorry. The question is natural log of 1 over the fifth root of e. What did I tell you about ln? It's in base what?
Ten.
Base 10.
E.
Base 10 or e?
Confusion. That's what I have. Yes, ten. Yes, E.
Log is the one which we're talking about, base 10. So ln will always have base e. There is nothing like ln base 2. It's just ln base e. You get my point? Now, if you want, that is if you want yourself. It depends with what you want. The one which we have here, okay? The one which we have on top, it is the same as I can make it to be the power, so it can be negative 1 to the power negative 1. But if you don't want, you can just equate this equal to x. Then you are trying to solve the value of x. You remember it is to base e. So you can say e raised to the power x is equal to 1 divided by the fifth root of e. Have you seen what I've done? Have you seen what I have done?
Yes, sir.
Now, when I reach at this point, what I need to know is this one here is the same as negative. I can put it outside. I can say e raised to the power x is equal to the root of fifth root of 5 of fifth root of e raised to the power negative 1. This one now I'm going to put it here as negative 1. How can I remove this fifth root? Okay, let's assume that we have got x is equal to, or let me do this. Let's say we have got x to the power 2 is equal to the root of 3. If I want to get rid of the square root, what do we do? Okay, let me just put x alone, just like that. What do we do for us to get rid of the square root?
We square both sides.
We square both.
Yeah, we square both sides.
We square both sides. Yes, so if I square both sides, the square root is going to go. So here I've got 5. So I'm going to say raised to the power 5 everywhere. What do I mean? I need to say this should be to the power 5. Even here, I'm going to say to the power 5. So that the 5 and the fifth root is going to be cancelled. Then I'm going to remain with e to the power 5x to be equal to negative 1 still. So it's going to be e raised to the power negative 1. Have you seen what I've done? I have multiplied to the power 5 so that the fifth root of 5 should cancel out with the 5. Then I need to do to the other side the same thing. So this one is like this is to the power that. So it's going to be x times 5, which is 5x. So e to the power 5x is equal to e to the power negative 1. So e and e can go, and I'll remain with 5x is equal to negative 1. So the final answer will be x will be equal to negative 5 over 5, negative 1 over 5. Bron. Okay. Here is another method. If this is giving you headache, let me show you another one. So another method which I'm going to show you is this. This one, do you understand the fact that if I've got square root of x is the same as x to the power half? Do you know that? Guys, do you know that the square root of x is same as x to the power 1 over 2? Do you know that? Okay, if you don't know, you need to know. The square root of x is same as x to the power half. So here what I'm going to do is this. The cube root of x, the fifth root of x is the same as x to the power 1 over 5. So this can be changed as, I can change this to be ln of e raised to the power 1 divided by 1 over 5. Because 1 over 5, this part here, e to the power 1 over 5, is the same as the fifth root of e. Now, since there is 1 on top there, to get rid of this 1, I can put a negative. So it's going to be ln e of negative 1 over 5. The property of log allows us to shift the power to be in front. So this power can be in front. So it's going to be negative 1 over 5 is equal to e ln e. Not is equal to here. It's supposed just to be ln e. I'm going to have ln e. But I said ln e is going to be 1 because it's like ln e base e is 1. So the final answer will be negative 1 over 5. This is simple, right? Guys, this is just introduction and it's giving you nightmares. Hmm?
So do you mind
repeating it. I lost my internet connection.
So here what we are doing, sir, is we have got ln the root of the fifth root of e, then on top there is 1. So we know that if I've got the square root of x, it's the same as x to the power half. If I've got the fifth root, or maybe the cube root of x, is the same as x to the power 1 over 3. So what of the fifth root of x is the same as x to the power 1 over 5. You have seen, right? Now, here what I have is the fifth root of e. So it can be written as ln 1 over e to the power 1 over 5. I've removed the square root. To remove this 1 is the same as just putting negative where the power is, meaning I've removed the 1. So ln e raised to the power half, or to the power 1 over 5. The property of log allows us to shift the power to be in front. This is the power. It can be in front. So it will be negative 1 over 5 ln e. Ln is already in base e. So ln e base e is 1. So it's negative 5, negative 1 over 5 times 1, which is going to give me negative 1 over 5 as my final answer. You have seen it?